right, welcome to our Unit 4, which is a little bit with geometry as well, congruence, similarity, and our transformations unit. But we're first going to start with congruence and similarity of geometric objects. So lesson 1, we're going to start with, here we go, starting with congruent figures. Let's go ahead and fill in these notes. These will go pretty quickly. Congruence comes from the Latin word which means to agree. So congruent figures agree with each other. Congruent shapes have the same angles or the same shape and the same size. They're exactly the same. They might be turned or rotated or flipped, but they're basically the same shape. The geometric symbol to show that figures are congruent looks very much like an equal symbol. It's an equal symbol, and then it has this little kind of squiggly thing over it. But this is the geometric symbol to show that two shapes are equal rather than that two numbers are equal. And this is just, why do you think that there's a difference between the equal sign and the congruent sign? Why do we have different signs to use for geometry rather than in algebra? Go ahead and give me your thoughts there. But going on, we know that congruent figures have congruent corresponding parts. That means they have all of the angles, all of the corresponding angles are the same, and all of the corresponding sides are going to be the same. That's a really sloppy congruent sign there. So for example, there's different ways that we can identify what parts are corresponding when we have congruent shapes. So we want to identify the corresponding parts. So in this one, we have two triangles. And in the picture, whenever you see like a little, I'm going to call that like a little half moon there and a half moon there. So one half moon and one half moon for these angles means that these angles are the same. They have the same measure. So angle G is going to be congruent to angle R. That's how we would write that. And then I'd write two little half moons here to show that this angle is not the same as this one, but 2 corresponds to 2 over there. So angle S is congruent to angle K. And then obviously we end with 3 little half moons, so there's angle P and F. So angle P and F are the same, so angle P and F are corresponding. And then we can do the same thing with our sides. So let's see, G and GS, it goes from 1 half moon to 2 half moons. So there's segment GS. That's going to correspond to going from 1 half moon to 2 half moons, RK. So GS corresponds to RK. And since these figures are congruent, those sides are the same. And then we have GP, which is here. So that's 1 half moon to 3 half moons. And I'm going from 1 half moon to 3 half moons, so RF. So those are the ones that are the same. And then I don't think we did PS or SP. So segment PS is going to be congruent to, let's see, this one right here. And I do want to go in order. So if I did 3 half moons to 2 half moons, I'm going to do 3 half moons to 2 half moons. That's FK. Technically, I could say KF, because KF is the same thing as FK, but there you go. So that is how you would label all of the corresponding parts. In a triangle, you will have 6 corresponding parts, 3 angles and 3 sides. So we need to practice, not only practice how to read this, but how to write all of the corresponding parts using correct geometry notation. So we want to identify all 6 of the corresponding parts by picture and by congruency statement. That means if I didn't tell you this right here, if I didn't say that triangle ABC was congruent to triangle DEF, so if you didn't see that congruency statement, you should be able to take a look at the picture and write all 6 parts. Also, if you didn't see the picture, if I just gave you the congruency statement, you should be able to do all 6 parts from that. So let's go ahead and do different ones from, here we go. I'm going to concentrate on the pictures first. So these 2 triangles, I know that they're the same. All of the corresponding parts are labeled. So I would write, let's do angles first. Angle A is going to correspond to angle D. Angle B is going to correspond and be congruent to angle E, and angle C is going to be congruent and correspond to angle F. So the angles are pretty easy to see. And when we're using, when we have congruent figures, I use these little hash marks as well to show that they're congruent. So 1 hash mark and 1 hash mark shows that those correspond, they're congruent. 2 hash marks shows that these 2 segments are congruent, and 3. So I would have, I'm going to start with AB, I'm going to start with my 1 hash. So I'm going to start with BC is congruent to EF. Then I'm going to do my 2 hash marks. AB, technically I would need little lines over these to show that they're segments. AB is congruent to DE. And then my 3 hash marks, AC is congruent to DF. So that's pretty easy from the picture. Let's go ahead and kind of go over these. If we didn't have the picture, there's nothing there, and all I gave you was triangle ABC is congruent to triangle DEF. How would you know what's congruent to what? When I say that 2 triangles are congruent, I have to be very careful of the order. So I have to make sure that the order that I put these points is the same order that I put these points. So therefore I have to make sure that A, like angle A, corresponds to angle D. Angle B corresponds to angle E, and angle C corresponds to angle F. So first, second, third, that the order matters. I can also go ahead and go segments AB, so my first 2 have to correspond to DE, which they do. My second and third, BC, has to correspond to EF, which they do. And then first and third, AC, has to correspond to DF, which they do. So the order matters when you're talking about which triangle is congruent to what triangle. Go ahead and look up Math is Fun and answer those questions about congruency and congruent shapes, and how you can kind of start manipulating them in your head and figuring out what parts are congruent to what parts.